Hi, I'm Graupel, and I'm super cool. Literally. A lot of people don't know my name, but I'm a star player on a pretty amazing team. I want to introduce you to the other players: snow, sleet, freezing rain, rain, and hail. And me, Graupel. Can you tell which is which? Nice job. The 6 of us are all part of the water cycle, which is necessary for life to exist. Not only do we make life possible, we keep things interesting. Sometimes we give people a day off of work or school by making travel impossible. We can cancel any outdoor sporting event or concert, but we also keep people active by occasionally making them run for their lives. It's always exciting to be a form of precipitation. Even though we are necessary, not everyone likes us. Lots of things can affect people's opinion: time of year, what type, how much, how quickly, and even what has happened recently can affect whether people are thrilled to see us or whether they grumble about the lousy weather we're having. I want to show you how we are made, what we look like, the impact we have on people, and some famous examples of when we cause trouble. My friends and I are all made of water, and we all form in clouds, but that is where our similarities end. It all starts with the water cycle, so let's check it out. The water cycle has 4 main parts: evaporation and transpiration, condensation, precipitation, and collection through runoff. Evaporation. That's when water changes from a liquid to a gas. Examples of that would be steam rising from a boiling pot of water or a puddle drying up in the sun. Transpiration. That's the process where plants give off water vapor through their leaves. An example of that is sometimes that evaporated water forms visible clouds you can actually see in the trees. Condensation. That's the opposite of evaporation. It takes place when water vapor goes from a gas back into liquid form. Examples of condensation are clouds, or when dewdrops form in the grass. Precipitation. Now, this is where it gets interesting. That's any form of water that falls to the Earth's surface. Examples would be rain or graupel. And runoff. When precipitation happens, some is absorbed right into the ground. But the water that can't be absorbed flows over the land and into nearby waterways. Examples would be creeks, streams, and rivers. Hey, now that you understand what the water cycle is, I want to talk about another idea: what it means to be super cool. So, what does it mean to be super cool? Well, we all know that water freezes into ice at 32 degrees. Supercooling is the process of lowering the temperature of water below 32 degrees without it freezing into a solid. How does that happen? For water to change from a liquid to a solid, there needs to be tiny particles in the water to allow the ice crystals to start forming. If the water is pure, however, with no particles for the ice crystals to form onto, the water can stay in its liquid state even as its temperature continues to drop below 32 degrees. It's amazing. Similarly, for water vapor to condense, go from a gas to a liquid, and form clouds and precipitation, there needs to be a dust particle or some other tiny object in the air for the water vapor to condense onto. If the air is pure and clean with no particles, condensation won't happen, so no clouds. There's a neat way you can actually see this happen with an experiment you can do at home. Okay, so here's the super cool experiment. Step 1. Get a plastic bottle of distilled water. Tap water won't work because it has minerals and other impurities in it, which would allow the ice to form when it reaches 32 degrees. But purified water has no impurities, which allows you to cool the water below 32 degrees without it freezing. Step 2. Place the plastic bottle in the freezer. The bottle has to be kept still during the freezing process, so if possible, tell friends and family not to use the freezer during the experiment, and be careful to place the bottle where it won't fall or be disturbed. Step 3. Leave the water in the freezer for about 2 to 3 hours. If you want to know when it's done, you can also put a bottle of tap water in the freezer next to your purified bottle. Starting at around 2 hours, gently open the freezer to check on both bottles every 15 minutes. Once the bottle of tap water freezes, the pure water should be supercooled and ready to test. Note, if your distilled water also freezes, you may have waited a little too long, bumped the bottle, or the water wasn't completely pure. That's okay, just try again. Step 4. Time to crystallize. Remove the pure bottle of water from the freezer. Be careful. A quick motion can cause it to change into ice. Now comes the fun part, instant crystallization. There are 2 ways to cause the water to freeze instantly. 1. Shake the bottle. Or 2. Pour the water onto a piece of ice. After shaking the bottle, the water should rapidly freeze inside the bottle. If you open the bottle and pour the water onto a piece of ice, the water will instantly freeze as it hits the ice, creating a column of slushy ice. Talk about super cool. All right, now you know about the water cycle and the process of supercooling. Time to learn about each type of precipitation, including me, Graupel. Let's start with an introduction to rain. Here's how it happens. Water vapor condenses around dust particles in clouds, forming tiny water droplets or ice crystals. As more water condenses, they grow, eventually getting too heavy for the cloud to hold, so they fall out of the cloud and down to the ground. Rain is necessary for farmers to grow food, but if rain is heavy enough, it can cause flooding, which is very dangerous. Here's how rain forms. Rain may start as ice, even in the summer, but it melts as it falls through a deep layer of warm air above 32 degrees. The temperature is above freezing all the way to the ground, so the raindrop will land on the surface as liquid water. Sometimes the rain evaporates before it reaches the ground. Then it's called virga. Here's an example of what happens when rain goes bad. Tropical Storm Irene. Irene proved it's not always the strength of a storm that's important. On August 29, 2011, Tropical Storm Irene moved into the state of Vermont with minimal wind but very heavy rain. Rain totals ranged from 8 to 11 inches in less than 24 hours, resulting in widespread flash and river flooding. Damage estimates in the United States were estimated near $13.5 billion, making Irene one of the costliest hurricanes on record in the country. In Vermont alone, more than 2,400 roads, 800 homes and businesses, and 300 bridges, including some historic covered bridges, were destroyed. Here's a look at some of the news coverage of the flooding during Tropical Storm Irene.
I'm Fox 44 Sky Tracker meteorologist Nick Johnston here in Mendon, Vermont. Now, Route 4 was completely destroyed. Thankfully, this bridge has been spared, but not by much. The water rushing just inches below this bridge. Thankfully, it looks like this bridge will be spared. There have been no structural fractures, and it looks like the bridge is holding. Over here, you can see, while the bridge was spared, this small house has been completely consumed by the river. You can see it's already ripped the siding off, and it is being swallowed up by these raging waters. I'll continue to have updates for you in documenting this dangerous situation. In Mendon, Vermont, Nick Johnston.
Flooding is extremely dangerous, so if you ever encounter floodwaters, first, get to high ground, and second, never try to cross a flooded roadway. Now let's talk about freezing rain. Freezing rain is made of raindrops that are super cool. The raindrops are super cooled by a layer of freezing air. So when the rain lands, it freezes instantly, just like the supercooled distilled water on the ice cube. This creates a glaze of ice on the ground, cars, trees, power lines, and other objects. If freezing rain keeps falling for several hours, ice continues to build up. This can result in major damage, downed trees, and power outages. Here is a look at how freezing rain develops. Freezing rain starts off just like regular rain. It melts as it falls through a deep layer of warm, above freezing air. But then it falls into a shallow layer of cold, freezing air at the surface. This supercools the raindrop. It does not have enough time to freeze before hitting the ground, so it lands as liquid. But because it is supercooled, it instantly freezes on contact with anything that is at or below freezing, creating a layer of ice. Bad freezing rain. One of the worst examples was the ice storm of '98. From January 7th to 9th, 1998, a disastrous ice storm hit parts of upstate New York, northern New England, and southeast Canada. Ice accumulations were as much as 3 inches thick. Millions of trees, power lines, and whole electrical towers collapsed under the massive weight of the ice. 4 million people were without power, in some cases for weeks. 44 people died as a direct result of the storm, and total damage was estimated at more than $5 billion. Time to talk about sleet. Sleet is like slush falling from the sky. Sleet is similar to freezing rain, but sleet freezes into ice before landing on the ground. Even though sleet and hail are both frozen balls of ice, sleet is much smaller than hail. Sleet is generally wet and clear in appearance. If sleet continues, roads can quickly get covered in ice, making it really hard to drive. Sleet starts the same as rain and freezing rain. It melts as it falls through a deep layer of warm, above freezing air. However, sleet then falls into a deep layer of cold air at the surface. Unlike with freezing rain, the deep layer of cold air allows the raindrop to refreeze into little chunks of ice before hitting the ground. The sleet storm of 1987. In February 1987, a winter storm developed over the southeast United States. Between February 16th and 17th, sleet was measured from Kansas to North Carolina, with the greatest accumulation in central North Carolina. Some areas received close to 8 inches of sleet, resulting in collapsed roofs and the closing of some businesses and schools for a week. Now we are going to take a trip into the freezer to talk about snow. Snow forms when water vapor freezes into ice crystals and then collects into snowflakes. When the snowflakes get heavy enough, they fall from the clouds as snow. For snow to occur, it has to be near or below freezing. Snow can be light and fluffy or very heavy and wet. Wet snow is good for making snowmen or packing a snowball. Isn't snow beautiful? But it can also be very dangerous, making travel impossible and causing roofs to collapse. Here's how it happens. Most precipitation that forms in the colder months starts off as snow because the top layer of a storm is usually very cold. Precipitation will stay as snow when the temperature remains at or below freezing all the way from the cloud to the ground. If the snowflake melts at any point, it will fall as either rain, sleet, or freezing rain, depending on the conditions at the surface. If it's warm at the surface, it may melt and fall as rain. Cold at the surface, freezing rain. A deep layer of cold at the surface, sleet. It has to stay freezing for there to be snow. But snow, like most forms of precipitation, can also be nasty. Enter the storm of the century, aka the Great Blizzard of '93. From March 13th to 14th, 1993, this storm was a monster. Beginning on March 13th, snow fell from Florida all the way to Canada. Snow totals ranged from 4 inches in the Florida Panhandle to 35 inches in Blairsville, Georgia, to 43 inches in Syracuse, New York, along with 40-mile-per-hour winds. Some affected areas in the Appalachian Mountains saw 5 feet of snow, and snow drifts as high as 35 feet. Roof collapses were widespread, as were stranded motorists. About 10 million people were without power, and damage estimates were well over $2 billion. This is incredible. About 40% of the U.S. population was affected by this one storm, with a total of 208 deaths spread across 13 states. Snow can be dangerous to drivers, even in small doses. A snow squall is a type of storm that produces a brief but heavy burst of snow. Here is time-lapse footage of a snow squall hitting the New York State Capitol on January 30th, 2019. It only lasted 15 minutes, and it only dropped half an inch of snow, but the whiteout conditions and icy roads it caused resulted in a 21-vehicle crash. The crash included tractor-trailers and injured a New York State trooper. Here's a look at the 4 types of precipitation we just covered, all on one page. Can you see how the temperatures in the atmosphere determine what type of precipitation lands on the ground? The last 2 types of precipitation, hail and graupel, are a little different. Their formation is less about the temperature in the atmosphere. It's more about a specific process involving our favorite, water, that is super cool. Hail is balls of ice that fall from the sky. Hail ranges in size from just 0.2 of an inch, roughly the size of a pea, to 8 inches in diameter, the size of a volleyball. That 8-inch hailstone fell in Vivian, South Dakota in 2010 and weighed almost 2 pounds. Imagine that falling from the sky. Hail is made in thunderstorms and usually happens in the warmer summer months. Depending on the size, they can do a lot of damage and even kill people and livestock. Here's how it forms. Hail starts as a frozen raindrop. As the chunk of ice starts to fall, the strong winds of the thunderstorm updraft continue to lift that little hailstone back to the top of the thunderstorm, where it gets coated with supercool water. As you know, that water freezes instantly, forming a new layer of ice around the hail. This process happens over and over again until the hail is too big and heavy for the updraft to lift. Then the hail falls from the cloud, so watch out below. Bad hail. On May 8, 2017, Denver, Colorado was hit with a catastrophic hailstorm. Baseball-sized hailstones pummeled the West Denver area, resulting in extensive damage to buildings and vehicles. The storm would surpass the state's costliest wildfires, force the Colorado Mills Mall to close for 8 months, and caused $2.3 billion in damage. The last person who was actually killed by hail in the United States occurred on March 29, 2000. The victim was Juan Oseguera, a 19-year-old who died from head injuries after being hit by a softball-sized hailstone in Lake Worth, Texas. Okay, we've covered the rest. Now let's learn about the best, in my humble opinion. Graupel is unique and relatively rare. I'm basically a cross between snow and hail, which is crazy if you think about it. Hail is a large ball of very hard ice capable of doing damage when it lands, while snow is light, fluffy, and delicate. So what gives? Well, I'm like hail in that I need supercooled water to form, but I stay small, light, and delicate like a snowflake. I look like a tiny little snowball or a little ball of styrofoam. It's always memorable when I come to town, since usually people haven't seen me in a long time, and some of them may have never seen me before. I may be small, ranging between 0.08 of an inch and 0.2 of an inch, but I am pretty special. Isn't that right, Abe? You better believe it. Check out how I compare to a normal penny. The reason I'm rare is that it takes special conditions for me to form. There has to be a mixture of frozen and non-frozen water in the cloud. Graupel showers usually only last a few minutes. I can also melt quickly, leaving no trace. So if you see me, take a picture. I start off as snow, but then I encounter tiny drops of supercooled water. The drops instantly freeze into small ice crystals, which coat me and usually make me round. The ice crystals are also why I often appear white. Okay, so I'm pretty cool. But have there ever been times when I caused major problems? Nope. I may have caused 1 or 2 car accidents, but a major disaster? Never. There are several reasons. 1, I'm rare. 2, I'm usually brief. And 3, I often melt away quickly. Okay, there is one thing. Sometimes, when I happen in the mountains, I can lead to avalanches. I don't grip like normal snow, so if heavy snow falls on top of me, it can slide. But hey, nobody's perfect. Hey, thanks for joining me. I bet you now know a lot more about the different types of precipitation, especially Graupel, and now you can explain the differences to your friends and family. You can also try to spot and identify the different kinds of precipitation in the real world. Have fun, and I'll see you next time.